Let's get started with session 2. So in session 1, we really talked about the terminology for everything. We talked about using your container, right? The being able to pull and run in a couple of different ways. We talked about how to share your container file, how to share your container. This session is going to be more about making a container file and then also building the container file. So just to kind of give you an understanding of how things are going, the pulling and the running are things that, if somebody has a container and you have trust in it, that are relatively easy to do. That's why they're in session 1. Making the container file, making your own containers, these are things that are slightly more complicated. And so we're building upon our session 1 here with session 2. First with the container file. Okay, so container files look messy and complicated, but I want to assure you that they are absolutely not. If you have a script for how to install your code on some sort of system, you are probably 80% of the way there. Really, all that we have to do is wrap the script that you have with some of these commands that are used for Podman HPC. They're also used for Docker to be able to do whatever you need to do, whether that is,
Got it. And why didn't it, just a sec.
Sorry, I had the screen up before to be able to find people, but I don't have that now.
I muted.
Thank you. I appreciate that, Helen. Okay, so as I said, if you have a script, you're 80-ish% of the way there. So you'll see here with some of the run commands, like if you take away that word run, right? So let's focus on the red for right now. All these things are doing are things that you would naturally have in a script or typed in. And we're just putting the word run there to be able to let Podman HPC know that that is something that we need to run. So let's take a step back, right? Let's say that you have your installation process for whatever code. Now, when we're building our container file, right, and this is what's going to be used to build the container, the first thing that we need to do is choose some sort of library, some sort of operating system to use. So here we're using Ubuntu 24.04. As I pointed to in the other registries before discussion during session 1, there's a lot of other places to pull from. And I also want to make it very clear that you don't have to pull a vanilla or base operating system. You can pull any container that you have access to. And so in our example later, you could build your own container with mpitch in it, or you can grab one that I've already built and build on top of it. I also mentioned before that you can grab something from NVIDIA that has, say PyTorch already installed and build on top of it. So when we're choosing our operating system, it's not just the operating system, it's the container that we want to have to build from. As we go through some of the rest of this, we can set working directories where all these things are going to be running. We can set arguments. You'll notice here that I have an argument that is set, and when I say an argument, it's set for within that container build process. So I've put this code ver here, and we use the code ver down here later on. So this is often a way to have a container file with one spot to change, say, the version for mpitch. And then when you do the wget to grab the code, when you do seeding to the right directory, untarring the right file, all these things, you can put in this argument to make that a little bit easier to change and do other things. I've already talked a little bit about some of the run commands. I do want to point out, and I have this listed on the slide here, but I do want to point out 2 things here. So the first is that we often combine run commands so that -- is saying do this and something else, and then you'll a lot of times see slashes to have multiple lines. The other thing to point out, especially this first set of commands here, is that when you're building from, say, a vanilla base operating system like Ubuntu, you will likely need to do some updating, maybe grab some system libraries. This is going to be different from when you log on to Perlmutter and there's a lot of stuff already installed, right? In your bin directories and your sbin directories, libraries that are there. that if you're building from a vanilla operating system or even a very simple base operating system, that you might have to add, right? And so using within Ubuntu, using apt-get to update what is there and install other things, for example, wget, this might be something that you have to add that wouldn't be included in that bash script for your installation that you started with. It's also important that we try to do as much of this as possible without doing any sort of interaction. And so, for example, with the apt-get install, we do the -y to say yes for all prompts, just because, yes, we want to install this and take however much space. So we want to make sure that as much of this is done without our interaction as possible. Other things that may be important, right? So we can set up environment variables within the container file. So these will be available and accessible whenever you, whenever the container is running itself, right? These are not set outside of the container at all. It's just for inside. You can use a copy from within inside, right? This is similar to if you do run and then CP, the two files, it just does it at a slightly different level. And then we also talked before about the entry point, right? So if you want to do something like entry point echo something so that whenever the container runs and you do the entry point, it'll always do this. For example, the lolcow, right? So you're going to have something there at the entry point if that's something you need. A lot of times, what people will do is just put things in the path or add something to the path, and we'll see an example of that in the in our exercise here today, where I just add something to a different directory so that it's available, and then we'll call that from outside of the container. So I do want to point out, right, if you copy and paste this in, this will not work, right? I've really just done some dummy arguments here to make sure that we can look at the different possibilities for what to include in a container file. And my suggestion is going to be, when we get down to the exercises, I'm going to be shooting, or I have a link to a Google document so that you can see everything that goes in a base container file that I'm going to suggest that you use for the exercise, as well as the commands that I used in order to create the container. And I think that I also put the commands to push it up onto the registry. So you'll have access to all of that, but that'll be a good place to get started. There are, other places that you can look at possibilities for container files. Right, so we have some of this in the documentation and on a GitLab site. In a shifter there's a shifter introduction that was given a while ago that has some information here. So the containers for HPC slide intro, this is pretty similar to what I've included in here because I used most of those slides to build this. I do want to point out that I have this Docker file basics. Things that work in Docker should work for Podman HPC. And so because this is all because of the OCI compliance thing. And so I would suggest that you have this available, but if something doesn't quite work, if something needs a little tweaking here, that might be. And then the same with the NVIDIA container files. NVIDIA has actually done a really nice job of making container files available for most of the containers that they put out. Sometimes they build upon each other, and so you have to go back a couple of different container files ago, or containers ago, to find the thing that you think is important. But that being said, NVIDIA has actually been much more open than I would have anticipated, and I'm very thankful for that with the container files. Okay, so our next step is to actually build the container. And I think that I've mentioned this a few times, but we can only do this if we're on Perlmutter using Podman HPC. And so if you want to use Shifter, which you're more than welcome to do, you can push it to a registry and then pull it down with Shifter. You can also, and I'll have a couple of slides or a slide on this, create your containers, say on your personal laptop, to push up to a registry and pull down. And you can pull those down with either Podman HPC or with Shifter, it doesn't matter. But for building on Perlmutter, it's Podman HPC. So the example that we'll go through is just for Podman HPC. And when we get to the exercise, you'll see that the build part is just with Podman HPC, but I do, in the I have a bonus section to say, can you push this to a registry and then pull it down and use it with Shifter? There's no reason why you should not be able to do that with any container. Okay, so let's talk about how to actually build the container. I spoke before about all of the stuff that can go into a container file. They can be very complicated, but they can also be very simple. So this simple two-liner here, right, from Docker.io library Ubuntu 24.04. So that's the operating system. It will download that, and it will give me a no lols here, right? So I'm putting in an entry point to say no lols here, and then I can build it. So this is a two-line container file in a one-line build thing. So again, this is very simple. This is not normal. Most container files are going to be more impressive than this, but this works. So let's actually look at this with a little detail, right? Again, we have to, in our container file, start with some sort of base operating system. And again, that can be a very complicated container that you are just building, adding something to, or adding some functionality to. But here, we just have, Ubuntu is pretty standard. And then we have the entry point so that it does something. We create the container using podman hpc build, right? So that's the command that we're using. And then we're going to tag the container, right? So we have to give it the name and the version number. And then we're going to say, do this for the container file that is here. So I hope that it's easy enough to see. There's a period here at the end of the create a container line. And that just says, use the file that's named container file that is in the directory that we're in. Now you can actually give it, I think it's -F to change the file name and do container files of all different names and all different places. But this is the standard way of doing things. This is what I'm going to be showing today. Just know that when you name something container file and you're in that directory, that's what you're going to be building. And again, we build using a simple command. We have to give it a tag with the name and the version, and we are ready to go. So when we do this, okay, sorry, I'm going to back up very quickly because I want to point out one thing. So in our container file here, right, so we have that base operating system, and then we also are adding to it in the create a container, something called no lols. So if I look at the viewing the container, right, so podman hpc images to show all the containers that are available, after I've built this, it will show both the base, right, because podman hpc is going to pull this, as well as the new thing that I built. So this is fairly simple, right? Like we know based on what we pulled and what we've built, what's going to be there. But I just want to point out that the things that you pull, even if you're pulling them to use as a part of something else, are going to show up in your image, in the image cache that's there. All right, so when we build this, unfortunately, you're only building this on the login node that you're in. And so what we have to do is to migrate this to Scratch. When we pull containers, like both when we pulled from Shifter as well as pulling using podman hpc, this migration happens automatically. And so we don't have to worry about this at all. However, when we build the container, we have to manually do this ourselves. And so all that we do is use the command podman hpc migrate and then tell it what container as well as the version number that we're trying to migrate. So if you update the container, like this is not some sort of link, this is a one-time thing. And so if you update the container, even if you name it the same thing, which you probably should not do, and we'll talk about that later, but if you update the container on the login node, in order for that to be accessible from Scratch for the compute nodes, you must remigrate, right? So migrate this again. So we'll get to this. I think that I pointed out a couple of different places, and it's going to be important for you to do in the exercise is to remember to migrate this. And again, we only migrate when we build. The migration is done automatically for us when we pull. Okay, so here's a couple of helpful hints, right? And we've talked about this a little bit already, but podman hpc allows you to do the build right in front of you and then not move the container at all, and do an easy test. So Shifter is fantastic. I love Shifter, but you do have to build elsewhere, push to a registry, and then pull. And so it's giving you extra steps. If that's a part of your workflow that you're already doing, by all means, go ahead and keep doing that. I'm not trying to tell you to stop, but if you're just getting started, Podman HPC is probably going to be a little bit easier. Again, migration is important, right? So the few times that I've done portions of this training before, the most common mistake that people make is forgetting to migrate so that everything runs fine on the login node, and then it doesn't run on the compute nodes. So please remember to migrate. And then finally, when you're doing these builds, everything is going to be cached locally, right? And so let's say that I pull in, an Ubuntu-based operating system, and then I download the GCC 14.0.1, and then I build GCC.14.01, and then I add some sort of MPI, and then I build my small application with that. So if I go through this process once and my build, right, for my application fails, when I try this again, all of the steps that were successful are going to be cached. And so that means that it's going to be very, very fast. This is super helpful because as you're debugging, right, as you're working on things, sometimes you're installing stuff that take a while to download, that take a while to untar, that take a while to go through a configure step, that take a while to compile. And if this is successful and you don't have to change anything above that within your container file, then this is going to be very, very quickly. And so when I am working on a particular login node, if I log off and log back on and get placed on a different login node, those cached things are not there. And so you can expect, if you're switching login nodes, or if you have to delete your cache for some reason, that things are going to take longer. But if you are actively working on something, the hope is that maybe the first time you go through this massive process, you have the time to go get a coffee, but you likely won't have that time if you go through this again. Okay, so just a couple of troubleshooting hints, and this has come from quite a bit of experience of working with people as they're building containers and understanding what is easy to get through and what is a little bit difficult. So when the container is being built, and you'll be able to see this when you're actually doing it, but it's going to say step 1 of however many, whatever it is, step 2 of whatever many, whatever it is. And it's going to output right on the screen for you, the standard output, right? If you weren't building this in a container and you were just typing those in, someplace where you have the access that you need to, whatever would be popping up on the screen is going to be showing up for you while you're building this container. And so if you get to a place that is problematic, right? Building my own code when I'm trying to link to, I don't know, some Petsy library, something like that, and my compilation fails because I can't find the library, what I can do is before that run command, right, just in the container there, or in the container file there, so comment out everything else, and then I can start that in an interactive mode. And so I do want to be very clear that an interactive container mode is different from our interactive job. And I'll show how to do this here, I think on the next slide, if not a couple more here in the future. But what we can do is we can go into the container, start it up, be on the command line within the container, and figure out what to do, right? Try that command that was failing, try to look around and find the files that I need to. And then once I can do that, then I can put that back in the original container file and go through it. And then also, in a lot of container files, you will see many lines put together on the same run command, right? So that ampersand allows you to tag a bunch of these together. We often do this, right? Have like one command for mpitch, one command for your application, right? So putting the wget or the git clone, putting the configure, putting the make install on all on the same run command. This can be helpful, right? Typically, these are all going to be together, and so having those cached like that is just fine. But you can break this up, right? So if you are troubleshooting something, you might want to break up some of those multiple commands that are put on the same run line to be able to have access. Right, so I mentioned that we can run containers interactively. And again, this is for troubleshooting. What we're going to do, and we're actually not going to do this at all today. This isn't included as one of the exercises, but might be something worth trying if you'd like to play around with this, is we're going to run the container pretty much the same way that we did before. However, we're going to add this -IT, which is going to run the container in interactive mode. And then we also have to give it a shell to enter. And I do want to point out that if you're getting some of these, teeny tiny containers, like the base containers that are meant for being as portable as possible, they might not include a shell. So you might have to add that before you're able to do this. But if you pull something like SLES or Ubuntu, all these will have Bash already installed. And so it's easy enough to fire this up. Once you're inside, do what you need to do to figure out, right? You can type those commands in specifically, but just know that anything you type in is going to be in the bash history that's in the container, that because that's an ephemeral file system will be wiped away as soon as you exit it. And so what you should do is copy and paste as you go so that you don't have to redo things. I've made this mistake more often than I wish to admit. So when you exit, you won't have access to the bash history anymore. You might be able to scroll up and see it, but make sure that you're copying and pasting what you need to know so that you can update your container file accordingly. Okay. So for containers with MPI, one of the things that we do to make sure that you get as good a performance as you can on our system is swap out your MPI for the system tuned MPI. Right, so that the vendor optimized libraries are fairly good. For the most part, that's where we see the best performance. And so we would like to be able to swap those out fairly easily. This works fairly well, right? So the API compliance between different MPI implementations is pretty good. The ABI compliance is not perfect. It's supposed to be getting better. The next version of the MPI standard will include this. It might take a little bit for all the implementations to also include this, but we're going that way, or we're moving in that direction. So to do this and be successful, right? So I've listed MPitch 4.2 to 4.4. This is really what I've been doing and successful with for C++ and Fortran programs. I know that if you are using Python's MPI for Pi, that you should use 3.4. I think 3.4 matches what we currently have on the system. But again, that's more an oddity of the vendor MPI and the version that's there. For the most part, the more modern versions of MPitch work quite well. And then when we're actually running this, we have to include the module call. So with Shifter, it's the -- module equals MPitch, and with Podman HPC, we just have the -- MPI. But for both of these, we also need to make sure that Slurm knows that we want this, right? So that we have access resources to it. So we have the -N2 and the -N2 here, depending on if you're looking at nodes or individual processes. So yeah, we're going to be using this during the exercise, which is coming up right now. So what I'd like for you to do is take a little bit of time and read the information on the links here. So if you want to build all this from scratch, you are more than welcome to, but I do have a base image that you can use as I do have an image that you can use as your base. I have the image that's available on Docker Hub, and so anybody can download that. And I've also included all the information for how this is built and the container file in that info is here link. And then I also am suggesting that you do a hello world using MPI. I'm sure that some of you have done this before, like to do this, and have your favorite version around. If you don't, I'd like to suggest that you use the repo that I have there. And I've actually, within that GitHub repo, in the README, I put in what the command to build that looks like. So again, you don't have to do this, but knowing that not all of you have a whole lot of HPC experience. I wanted to provide enough for you so that you're able to do this exercise in, 20 minutes or so. But we're going to create a hello world container that uses MPI. Really, if you're just pulling these things, it should be fairly easy. But I'd like to run this on a login node. Oh, sorry, I only want to do this with a single process on the login node, not two processes. I apologize, I missed that. Then after this, I need you to migrate that container over to Scratch so that we can run these on the compute nodes, and then run with a debug interactive job on two nodes and as a batch job on two nodes. So I think that this will probably take the entire time, maybe even a little bit more. But if you have more time, or if you'd like to come back to this later, kind of the next step to this, right? The next kind of process is pushing this to a registry and then pulling it back down. And because we've already done this with Podman HPC, try pulling it down with Shifter and try to run it, the same way on Shifter. So with that, so we are at 1:48, 10:48. All right, so at 11 o'clock, I'm going to come back and walk through the steps for how to do this. And I'll probably walk through all the steps. So it might take a little bit longer. Yeah, it might take a little bit longer. So my guess is that we'll come back and start session 3 in about 25 minutes. So again, we'll be monitoring the Q&A doc, and I'll be back to kind of show this live as a demo. And then after this, so that the third session is relatively short. Here's some tips and tricks, and then here's an introduction to some of the advanced topics. And yeah, we'll go from there. So good luck with your exercise. All right. I think I'm going to take a couple of minutes and walk through some of these things. First thing that I'd like to walk through is the container file that I used as a base. So the container file is listed here, right? So you can see the things that we were talking about previously. I have the from statement saying that we're going to use Ubuntu 22.0 or 22.04. I've set this up to add a couple of things that we need. To be honest, I don't think that all of these are needed for MPitch and for the hello world that are included. But I think that these are common enough if you're doing other things that are, some worthwhile things to include. We have some run statements. So this run actually gets rid of some additional files, hopefully making this container a little bit smaller, but isn't necessary. We're doing mpitch 4.2.2, and you see that I have a couple of arguments set up here so that I can reuse these. So I reuse these in the wget command, in the tar command, in the cd command, and then also in the remove command to get rid of all the unnecessary files to begin with, or once we're all done with the make and make install. And so the nice thing about this is that if you wanted to do, say try this out with mpitch 3.4, which is something that we've seen is generally fairly good for using with Python's MPI, which sorry, the name escapes me right now. But we can swap this out fairly easily. I don't think that going between the 3.4 and 4.2, there's any changes in what you need to do, just in locations where you're grabbing things and in the names of the files. So that's a more complicated container file. And then in order to build this, I built, so this is not something that you would have had to do, right? Because you have access to the container already. But if you'd like to build it yourself, you're more than welcome to. And then what I had tagged this in one location. I realized that I needed to put it up in a place where you all had access. And so I changed the name of it. I had to log into docker.io because even though the repository is public, I have to be logged in as myself to be able to push there. You all have read and pull access, but you don't actually have the ability to push to that unless I set it up so that you are able to. So that's what I've done here. And now sorry, I'll go back. So, and then also, let's just go to the hello world that I have. So the code, if you look, is fairly simple. There's nothing super special about this, right? I put this together, but these are the types of things that
Adam,
I've done.
do you mind increase the font size, please?
Sure. Thank you. I appreciate the heads up. How's that?
This is good. Thanks.
Okay. Yep. Thank you. Yeah, please call me out on that. It looks beautiful on my monitor, but I'm sure that it probably isn't coming through nearly as well as it could. Yeah, this is very basic, right? We're just going to figure out how many MPI tasks are there, figure out my individual task number, and then print something out saying that I am a rank of however total many, and I'm located on a specific node. And the reason that I like doing this is that when we, if you follow the exercise through and actually ran on multiple nodes, you get to verify that, yes, we're running on multiple nodes. And then the other thing that I mentioned to you is that in the README here, I suggested using these commands for getting this into a container. So this is, all we're doing is two different run commands. One of them is simple, it's just pulling this in. And then the other one is a little bit more complicated. We actually go there, we build this, and then we make the output be something that we can utilize. And then both in terms of permissions, and then also put it in a location that is going to be in the path of the container. I could omit this last step and add this to the path. That's more, to be honest, I don't remember why I did it this way, but that is up to you with how you would like to do things. So let me just go here to the exercise solutions. Sorry. I will bring my terminal up and increase the font size again. So I've listed out what the container file is, and I already have this in the location that I am, right? So I'm pulling from my the mpitch Ubuntu that we saw that longer container file in the Google Doc. I'm setting a work directory, which is really just where these things are going to go then. And then I'm going to, just like it said in the on GitHub, clone that and then build it with the commands that are listed. This is fairly straightforward, fairly small, but the other container file that we looked at is much more complicated. And what we could also do is, rather than build that container and then pull that in as the base here, I could just copy lines 3 through 7 onto the end of that and build that whole thing from scratch. I'm not going to do that here just in the interest of time, but you have the ability to do that. So I'm going to world, and I'm going to say 1.1 because I already have a 1.0 just to make sure. And again, I mentioned this before, but everything is cached if it's already been done on that node. Login 18, this happened to be the node that I logged on this morning when I woke up and ran through everything just as a sanity check to make sure that things were ready for today. And so because it was already cached, it ran very quickly. I do want to point out that I mentioned before that we have all these steps, right? So again, if we scroll back up, we can see, so each of these are lines, but they're steps as well. So 1, 2, 3, and 4. 1, 2, 3. Okay, yeah. So as we go through all of this, right? So we have the base. We are putting together this environment. So this is something that's local on Podman. That's not listed up here, but because of how Podman HPC works, we're giving it access to these things. So then we go back to setting our work directory and then the running statement. So if this had failed, right, we'd get an error here. And so I can say, this is wrong. Maybe I'll stop my container file, right? Come up here and comment out these lines. And then I could start the container file, the container that is built interactively, and go in and try to play around until I figure out what's going on. So everything, again, because we have it organized here, it's easy to go back and figure out what went wrong because you know the step. And so you can say anything after that step, you can just comment out, build a working container, go in and play around. All right, so we can run this here on the login node. Run my double minus sign is not working well together today. World 1.1 out. And because we're not doing anything in MPI, it's just a single task. So this is what we expect to see. We do have to migrate this over if we want to use the container on the compute nodes. And again, when we pull a container, Podman HPC and Shifter will both automatically do this migration. It's only because we have built this container, and since I've built it, I've updated it, that I need to do something slightly different. And that is migrate it manually. So Podman C migrate. I can type 1. Should be fairly quick. And then coming over here, so I will grab a couple of nodes. Oops. 2, I'm going to just do this for 5 minutes so that hopefully things go very quickly or start very quickly. Oh, good. So we did not set up an allocation for use today. We thought that all the things that we'd be doing, we'd be able to do on the interactive QoS and the debug QoS, which are generally very fast. And I hope that that has been the experience for everyone else here. If you did find that you had to wait around too long, please let me know. And in the future, when we offer this, we might set up an allocation for the various users to actually to use, as opposed to just using the interactive and debug queues that are available. Hello, come on. Here we go. All right, so I'm going to use srun, and I'm going to say -2 pmin HPC run. I have to clean up after myself, and then we're using MPI. And again, we have the -2 to make sure that that we're given access to the processors, and the MPI within that actually use those processors. World 1.1 out. And when this runs, it'll take just a minute to spin up and spit things out. We should see something very similar to what we saw before, only now we're going to have 2 processes. And because we had requested 2 nodes, we hope that there's going to be 2 separate nodes that showcase, I think that I had a typo in my name. Sorry. Pitch. Uh-oh. I only have 1.0 here. Hello world. Strange. Okay. So this is the output that I expect, right? Rank 0, 2, 1 of 2. So we have 2 different things, and they're located on 2 different nodes. So I'm going to exit out of my interactive job. And then, yeah, we have the Slurm for this. So I'm going to, rather than just run this right now, I'll show you, well, basically the same things that were there. Right, so we have the our sbatch commands here to get the resources that we wish to allocate. And then we also have the output file and the error file. And then we're running, basically the same command, the same command as when we're doing the interactive job. So now when I've run this, I have the .error file, so that's the standard error, and then the .out file, which is the standard out. So let's just cat the 2 of those together. Oops. And so because there's only something in the output file and not in the error file, the only 2 things that are shown here. And again, we have the 2 different values of the total MPI ranks and the 2 different nodes that we ran on. So I'm going to move on with session 3 now, but I would encourage you, if you weren't able to make any of this work, to continue working at it. And if you are going to be using Shifter, if that's something that you'd like to use, or just want practice doing something additional, right, try pushing your image to a registry and then try pulling it back.